First, I'll ask it to list the available documents. The client sends the access token with the request. The server validates it, and the tool returns the documents this user is allowed to access. This confirms that the token does more than confirm the exchange. It can authorize a real MCP tool call. Imagine this. Your company has an AI agent that needs to access internal docs, support, and engineering tools. But every MCP server is waiting for the user to authenticate. Instead, we're going to authenticate the user once through the company's existing identity provider and use that identity across the entire flow. That identity flow is called cross-app access. In this video, we'll recreate that exchange using the MCPJam's cross-app access debugger and see how to find the exact point of failure when the flow breaks. So, for this example, we'll be using Auth as the company's identity provider. I'm using an Internal Docs MCP server as the example repository. It exposes two simple tools. One lists the available documents, and the other retrieves those documents. After cloning the repository, make sure to install the dependencies. And don't forget to copy the example environment file. Before starting the server, replace the placeholder Auth values in the .env file with values from your own Auth application. You need to notice that the Auth configuration and the server configuration need to agree. The issuer tells the server which identity provider it should trust. The audience tells it which recipient the assertion is intended for. The client values identify the application participating in the flow. The MCPJam issuer and its JWKS endpoints are shown here. The authorization server must trust this issuer and use the JWKS to verify MCPJam's signature. Once you copy those values, you can start the server. The terminal confirms that the internal docs server is running and gives us the MCP endpoint the client will connect to. It also gives us the token endpoint used during the exchange. With the server running, I'll open the MCPJam inspector with the command shown here. The inspector should open automatically in your browser, but if not, you can see the local URL here. From there, we'll select the cross-app access debugger from the sidebar. Since the authorization server is also running locally, I'll leave the US-hosted issuer turned off. This keeps the test on MCPJam's local issuer, which the authorization server can reach from the same machine. If your authorization server was hosted publicly, you would turn this option on and register the hosted issuer in JWK values shown here instead. Now, I'll configure the Internal Docs MCP endpoint, choose the pre-registered client option, and confirm the client ID. At this point, we're only setting up the connection and making sure that MCPJam can reach that server. I'll be showing you how it works before running the exchange, so we can first understand every service involved and what moves between them. Let's start with the client. This is the application trying to access the Internal Docs MCP server on behalf of the user. Before anything else, the debugger checks that the issuer it's about to trust actually publishes MCPJam signing key. That's the verify issuer publication stage. If it fails before any request reaches your server. So it's worth checking first. The client first discovers which authorization server protects the MCP server and where the relevant endpoints are. These are the discover resource metadata and discover auth metadata stages. Next, the client communicates with the identity provider. In production, that may be Auth. In this test, MCPJam acts as the test identity provider and issues the identity assertion for the simulated user. That identity assertion proves who the user is, but it does not automatically grant access to the MCP server. Auth provides the identity information that proves who signed in, but that identity token does not automatically grant access for the MCP server. Next, MCPJam issues an ID-JAG for the simulated user. This is the mint ID-JAG stage. Think of the ID-JAG as a signed assertion that carries the user's identity to the next part of the flow and identifies who the assertion is intended for. The client presents the ID-JAG to the authorization server or token endpoint protecting the MCP server. This is the redeem ID-JAG stage. The server verifies who issued it, which user it represents, who it was created for, and whether or not it is valid. If those checks pass, the server issues its own access token. Finally, the client says that access token when it is calling the MCP server's tools. This last call is the authenticated MCP request stage. Now that we know what each step means, let's run the flow and watch all of those steps. The debugger discovers the services involved, issues an ID-JAG for the simulated user, and sends an authenticated request to the Internal Docs MCP server. When the flow completes, every stage is green. Later in the playground, we'll use that token to call the actual Internal Docs tools and verify what this user can access. Now let's take a look at this ID-JAG. Instead of looking at a one long encoded string, the debugger decodes it so we can read each claim. The issuer tells us which identity provided created the assertion, the audience tells us which recipient it was created for, the subject identifies the user represented by it, resource identifies the MCP server, client ID identifies the registered client, and exp shows when the assertion expires. Other validation information tells the server whether or not the assertion can still be accepted. But you don't need to memorize every claim. We just need to compare what's in this assertion with what the server expects. So, if the exchange fails, we know where to start looking. For the first failure, we'll test what happens when the assertion has the wrong audience. I'm going to the .m file and changing this variable to true. This does not change the JWT. It changes the audience list that the demo considers valid, giving us a control way to reproduce an audience mismatch. I'm going to restart the server so the environment change takes effect. Go back to the cross-app access debugger and run the same exchange again. This time, the exchange fails. The earlier step still worked, so we know the assertion reached the authorization server. The failure happened when the server tried validating the ID-JAG. Opening the failed result, we can see that the audience in the assertion did not match what the server expected. The second failure happens at the same exchange stage, but for a different reason. This time, we'll set the expired assertion variable to true and restart the server. When we run the flow again, it sends an expired ID-JAG, so the authorization server rejects that exchange. Now, we'll run the negative test scorecard. The negative test scorecard checks if the authorization server correctly rejects invalid assertions. MCPJam tests several broken ID-JAGs, and the green expired result confirms that the assertion was rejected as expected. This helps us identify the expiration as the cause instead of guessing among invalid grant error causes. After fixing everything, we need to confirm that a valid access token can actually be used with the MCP server. I'm opening the playground to call the internal docs tools and confirm that the access token works in practice. First, I'll ask it to list the available documents. The client sends the access token with the request. The server validates it, and the tool returns the documents this user is allowed to access. Now I'll ask it to retrieve a document. The server validates the same access token and returns the document content. This confirms that the token does more than confirm the exchange. It can authorize a real MCP tool call. We can repeat the same flow from the terminal. First, you need to install the MCPJam CLI and then start the local inspector with this command. Next, I'll run the MCPJam cross-app access run with the internal docs server URL, the local issuer base URL, the simulated subject, the registered ID client, and the mcp.access scope. The CLI follows the same 6 stages we saw in the inspector and returns a completed result with exit code 0 when the flow succeeds. We use the MCPJam cross-app access debugger to run a successful flow, reproduce 2 different failures, and identify what caused each one. Then we use the access token to call the internal docs tools in the playground. And if you want to try this out yourself, you can find the example repository in the description along with other resources. Thanks for watching. I'll see you in the next one.